Hi, welcome to this month's weather briefing. My name is Alajos. I work at HungaroMet since January of 2025, and I work at the Unit of Aviation Meteorology as a forecaster. I finished my studies during this summer at Austria University. All right, so I would like to start this weather briefing with an interactive session. And I would like to ask everyone to try to mark on the map on the jet stream where the jet stream is. This is a water vapor channel from the MTG satellite. If you'd like to try to mark where the jet stream is based on this image, you can use the annotation tool. Amazing. Let me just switch to the next slide where we have the jet stream forecast from ECM. This, as you can see, is around the area where on the map. This is where sort of on the previous image you could see harsh change between the high water vapor content areas and the low water vapor content areas due to the turbulence mixing. On this next slide, you can see how the jet stream sort of acts as a barrier between two different air masses, as it is sort of also in line with the Rossby wave around the polar cell. If we move on, we can see that along the jet stream, there are multiple areas which have convective activity at the moment over the northwest part of Europe. We can see on this satellite image some frozen cloud tops, also over at the eastern part of Europe as well. On the cloud face, the cloud type satellite image, we can see similar information, some different formation types about the storms. With the composite natural and lightning images of MTG, we can also see that the convective storms and the lightning strikes are seen towards the east of the continent. This was at 9 UTC today, so since then there may also have been lightnings over on the northwest of Europe as well. Here is also the composite storm image of the MTG satellite, in which we can also see the convective storms that are formed by the jet stream and the frontal zones. This is the sort of general weather situation over Europe. This is a temperature map of the 850 hectopascal pressure level. We can see some low pressure areas over the north of the continent. And the next image is the theta, so the potential equipotential temperature specifically, with the same 850 hectopascal pressure level. Based on these images, this is going to be another interactive part. This is the surface pressure and cloud forecast, specifically the analysis of ECMWF, because this is the zeroth time step. I would like to ask everyone to see where the frontal zones are. Try to put the fronts, the warm fronts, cold fronts, maybe occlusion fronts, where you think there are any. Yes, I can see some frontal zones of the two low pressure centers over the north of Europe. One of them seems to have a wavy frontal system, which looks great. I will show you on the next slide what our forecasters have put on the map. So we have an occlusion here over the sort of Germany, Baltic, the frozen ocean or the icy ocean here. And then we've got the warm front and the cold front sort of waving its way towards the Atlantic. And then sort of over here in the northeast, we also have a frontal system that is also starting to occlude and weaken. I see that somebody has connected the two. That is very interesting as well, I think. Our forecasters have decided not to, but it is based on some of the maps very possible that it is sort of a connected system. So I will now talk a little bit about the forecast for the next few days, about a week. We can see the two on the wind map. We can see currently this is sort of around the current time that is projected. We can see the wind system draw out this cyclonic flow over the entire north part of Europe. This is the two low pressure systems that have formed this cyclonic system. And as we go forward in time, this is the projected wind system for tomorrow. We've still got over most of Europe, or the center part of Europe, this westerly flow that is left over from the sort of cyclonic systems. And as we move forward in time, we can see from the west, from the Atlantic, there is sort of this anticyclonic flow, this anticyclonic system that is approaching Europe from the west. And over the next few days, we expect it to reach Europe, but also the wind will pick up sort of over the Atlantic, which if you're flying towards America, that might be an issue with the wind. This is relative humidity and column water content maps for Europe. This is for today at noon UTC. We can see that from the west towards the east, there are high water content air masses approaching, and they are likely to bring precipitation more inland towards the east. As we go forward, we can see these air masses sort of breaking up. Tomorrow, we can see that it will be sort of over the northern areas and sort of southeast, the Mediterranean part of Europe. 2 days from now, it is still likely to be sort of a mixture. Towards the west, we will see a more humid air mass. but towards the east, it will stay relatively dry compared to the rest of the continent. And this is sort of how we're going into the next week. In the north, we're expecting a bit more humidity, but sort of towards the southeast specifically, we're expecting more dry or drier air, which is likely to affect crops and everything. This is specifically the forecast from ECM, the weather situation over Europe. This was sort of for today. So we have precipitation, pressure, and cloud. We've got some precipitation over mostly northern Europe at the moment. And then if we go forward in time, tomorrow we've got at noon, around noon, we've got some precipitation expected sort of over the west of Europe, specifically northwest and the north as well. Tomorrow, fun fact, is a national holiday. So we usually have a fireworks show in the capital and in many places in Hungary. So, and we at HungaroMet provide forecasting for this event. And we are a bit stressed about it because around Hungary, we're expecting some precipitation, but we're not sure if it's gonna be within the bounds of the country, within the sort of area that are expected to have fireworks. So we will see if we have fireworks tomorrow. As we go on in time, we will see a bit more precipitation move inland towards the east of Europe. And then as we go on in time, as the anticyclone west-southwest is approaching, there will be a bit less precipitation expected sort of in that area. The minimum temperatures are expected around these days, around 12 Celsius in the north, and then 16 to 20 in the south. But this will only get warmer as the anticyclone approaches and after the cold front passes through. So the maximum temperatures are expected to increase from today in the next week-ish. And we are expected to have maximum temperatures of around 35 to 40 degrees in the southeast of Europe specifically. In the northwest, we expect it to not get this high in temperature, so that will likely stay around 20 Celsius-ish. And now I hand over the presentation to my colleague, Zsófia.
Hi, everyone, and welcome as well from me. As you know, usually in the second part of the weather briefing, we talk about some past events happening between this weather briefing and the previous one. So I have tried to focus on a couple of phenomena which were going on around Europe in this time. And one of them, I'm pretty sure you have heard in the news about the Etna eruption and how it is affected also aviation as well. So I will just show you here one video of what is going on in Etna. I'm pretty sure you have seen this in the news as well, that there are a lot of ash and also some fires because of the lava going around. It's quite some view, let's put it like that, especially at the night time when we can see all the magma and everything going around. So it's very nice. But for you, my question is, in the next slide, is which RGB would you use to observe the volcanic eruption? So please use your annotation tools and try to mark the RGBs you would use to observe volcanic eruption. Don't be shy. These are just a couple of them listed here. You can mark several of them because several might be useful. So I see the true color is marked, the ash RGB is marked, dust RGB, fire temperature RGB. Nice. We will see what is happening. I will just try to erase and have you answer the next question. So if you would want to observe the volcanic ash, what of these RGBs would you use? It's similar to the previous question, but it's a little bit different as well. Yes, we see the ash RGB. Would we be able to see it in any other RGBs? And after you answer these questions, we will look at the RGBs and see what we can see in each of the RGBs. True color for the ash. Good. So I see no one marked the cloud phase or the cloud type. Not for the fire temperature either. Okay, let's see the last question and then we will look at the images. So what do you think? Can we see the lava from the satellite? And if yes, which RGB would you use? Would you try to see it? Think about the images we have seen in the movie. Yes, I see the fire temperature marked. Okay, nice, nice. I will just erase and then we will look at a couple of loops about the eruption. Okay, so here we have the true color RGB and the fire temperature RGB at night. So we will see this is a loop of 2 days, or almost 2 days, a couple of days. So we can see actually, as in the fire temperature RGB, it looks like it's a fire there, but it's actually the lava which we are looking at because of the temperature. And then we can see the volcanic ash. I will try to use this tool here. Oh, but then it stops. Okay, but you can, I'm pretty sure you can see the plume, the ash plume coming, and then the clouds are blocking the view of the ash, and then we can see when the clouds moves again, we can see them. I can start the, oh yes, it started again, so we can see the fire or the lava at the fire temperature, and we can also see the plume very nicely coming from the volcano. And you probably have seen in the beginning that if the ash plume is very dense, then we can very nicely see it over land. But if it's weak, then we cannot see so well because of the contrast. But over the sea, it can be nicely seen even when the plume is not so dense. Like here, we could see a little bit. So yes, you marked it right, that we can see in the true color and the fire temperature. So if we move on and we look at the cloud phase, then we can see the plume also in the cloud phase. And actually, we can even see this green dots in the middle where we have the volcano. That's actually the lava. And why it's looking similar to how we see the intense fires in the cloud phase RGB, also green dots. And that is actually because how we see the hot objects in this region. So if we go to the hot object detection, then we know that the hotter the object is, the shorter the wavelengths at it emits most. So we have here this nice figure. And actually, I looked up the temperature of the lava coming from the Etna is about 1025 Kelvin. So this is actually the the line which we are looking. So we will see it in the 3.9, 3.8 region, but we will also see it at 2.2. And some cases we can even see it in the 1.6, but that's not the best. So yes, we will see it in the cloud phase as well. And also we could see the ash. And you have also mentioned the ash RGB, that you would monitor the volcano detection with the ash RGB as well, and you would see it in the ash RGB. And actually, this is also a loop of it's about half a day, and we can see the plume coming from the volcano, and we can see different colors in this RGB. We can see some greenish turquoise color, and we can also see some red color, and if we wait, we will see some more red, more intense red coming out of the volcano right here, and then we can follow where it is moving. Then we can see also some green coming. So my question would be that which color shows the volcanic ash? Is it the turquoise, the brown, the red, or which one would you think it's the volcanic ash? You can try to use your markers. What do you think? Which would be the volcanic ash? So someone says the turquoise. So anybody else? Red? Okay. Yes, actually the volcanic ash is shown by the red. The turquoise is something else, and it's coming from the difference between the 10.5 and the 8.7 micron channels. And that is, yes, exactly, that is SO2. So that is SO2 coming from the volcano, which we can see with the green or turquoise color. Exactly. So we not only see the ash in the ash RGB, but we can also see the SO2 coming from the volcano. So I will just erase things and try to move to the next slide, which is a follow-up. I'm pretty sure you remember, or you have heard in the news that very large parts of the Europe, especially eastern part of the Europe, has drought in these days. And unfortunately, with all these droughts, there are quite some fires detected in the area of the Balkan Peninsula and other parts of the continent as well. So which RGB would you use to detect the fires? What would be your primary choice? Fire temperature RGB, yes. You can detect the fires, you can detect the smoke. Yes, exactly. With the true color, we can detect the smoke. And also, as we have seen with the cloud type, we can see some of the fires as well. Yes, very nice. These would be the first choices for me as well. I will just quickly erase this and move to the next slide, which is a loop. And so I would like you to mark the fires you see in this image. Oh, you are able to annotate. That's good. That's very good. So then it will run. Yes, we already see some fires there marked. Is there any place else you can see fires? Unfortunately, there are several ones in this image. Yes, indeed. I'm pretty sure you have heard the news about all the fires in Croatia, and also there were some, yes, in Serbia and Bosnia as well. Even we can see some on this image in Italy, North Italy, and also some are seen other places as well. And also we can see the nice storms developing over Italy. They are very nice looking. Yes, good. You were able to detect most of the fires in the image. Very nice. So this is just for you to remember that which are the channels which is used is 3.8. Sorry, it's a typo here, and also 2.2 and 1.6. And the hotter the fire is, the more extreme, then it goes to red to white in this RGB. And there is only one last phenomena which I chose to show you in this weather briefing. I will just try to run this loop, and this is a nighttime RGB, and you will see some strange behavior in this RGB, and I would like you to try to mark where you see this strange behavior. Yes, someone nicely put a line there. Yes, exactly. This is the strange behavior. This was during the solar eclipse, and we can see the nighttime RGB showing features which are only shown at nighttime, not at daytime. And I will move to the next slide, where we can even better see the eclipse moving through the globe. And this would be for us today, and I hope you enjoyed it. And if you have any questions, let us know, and thank you for your attention.